Okay, in the previous video we discovered the formula for the sum to n terms of a geometric sequence. I've gotten them written here for you, and a reminder that it doesn't matter which one you use, as long as you use the right version. And notice the position of the r's and the 1's. So here we've got r1, r1, and on the right hand one we've got 1, r1, r. So it doesn't matter which one you use as long as you've got those r's and the 1's and in the right order. All right, looking at example 18, consider the sequence 32, 16, 8. Notice that it is an infinite geometric sequence because it does not have an endpoint specified. So show that the sequence is geometric. Show tells us that we can use numerical examples. So we start with our last term and work our way back. So 8 on 16 is a half, and then 16 on 32 is a half. Therefore, we conclude that consecutive terms have a common ratio, and in this case it happens to be a half. Therefore, it is geometric. All right, question B says find the sum of the first 9 terms. So T1 is our first term, which is 32. R we've just calculated is a half, and N equals 9. So I'm going to use the right-hand version of the rule so that I don't end up with negative numbers. So Sn equals T1 outside of 1 minus R to the N on 1 minus R. So T1 is 32 outside of 1 minus a half to the power of 9 divided by 1 minus a half. If you put that into your calculator very, very carefully, you'll end up at 63.875. Now, because that's the only decimal, that tells us that there's probably a nice fraction associated with it, not a recurring fraction. So we can write that in mixed number form, which is 63 and 7/8, all of which can be done via your calculator. The next one says find the formula for Sn, so the sum to any number expressed in simplest form. So Sn is T1, which is 32, outside of 1 minus R, which is a half to the power of N, on 1 minus a half. 1 minus a half is a half. 32 divided by a half is 64, outside of 1 minus. Now I'm actually going to put the power of n on the 2 on the grounds that a, if we've got a on b all to the power of n, that's a on n to b on n, and 1 to the power of anything is 1. So I've just moved that power down. Then I'm going to distribute the 64 into the brackets, so 64 minus 64 on 2n. And hopefully you will recognize that 64 is actually 2 to the power of 6. So then 64, we'll just leave that one as it is, minus 2 to the power of 6 on 2 to the power of n equals 64 minus 2 to the power of 6 minus n. And that's as simple as we can get it. For example 19, find the sum of the first 8 terms of a geometric sequence. Actually, no, I'll go and do this one in the next little video. Okay.